Check her head out.
One of the simple things that we hear in safety is the hierarchy of safety controls. Even though it's very simple and easy to understand, sometimes when it comes to implementation, we find it difficult. One of the issues is that we believe that most believe subconsciously that once they apply a particular level of control, then others are not important, which is not true. And this video will also help us to enlighten general populace about what safety control means. Then when we say hierarchy of safety control, it means that there's a preference, hierarchy. One is higher, then one is at the end. That is why you don't just apply only one level of control, except from elimination. Because when you eliminate, because that is the first one, elimination. Elimination means that you are taking off that particular hazard, you are taking it off completely. No other thing, you are taking it off completely. Let's say, for example, you want to carry out a painting, which is a very common one and a very easy to understand. You want to carry out a painting task, and it involves maybe height of 3 meters, and you are like, you don't want to start going through the burden of going to that height to do the job using ladder or using scaffold, because that is already fall hazard. You already introduced an hazard. Then you're now like, okay, what we are going to do is that let us take the brush, let us extend the rod, a rod at the base, and use it to reach that height instead of climbing that particular height. In that case, you have already eliminated a particular hazard, which is fall hazard. Other hazard might be present, but that particular fall, you've already eliminated it. Nobody will be falling from that height. Then the next one is substitution. From the word, you are substituting a more hazardous situation with a less hazardous one. Let's say, so, for example, you have a particular equipment that requires high level of voltage for it to operate, and you're able to get another equipment that will do the same job, but requires lower level of voltage, which means that you have reduced the hazard. The electrical hazard is still there, but it has been reduced. Another example when it comes to process is painting. You can decide that because you want to do painting and you don't want it to get to more people, you don't want people to inhale the paint, instead of using spray painting, which can be faster, you decide to use brush. You have reduced the possibility of people inhaling that chemical. Yes, the other one, which is brush, will still be inhaled, but you have reduced it. So that is substitution. So substitution can go along with process. You can substitute a process, you can substitute an equipment, you can substitute a substance, and so on like that. The next one is engineering control. And when we talk about engineering control, from the word engineering, it is not only limited to barrier. People think that engineering control is only about barriers that you put in an equipment to prevent maybe the spark or someone getting drawn in at any point or the likes. Engineering control means using advanced technology to create a control that will help to reduce the effect of an hazard. For example, apart from the barriers that we all know, if you look at some equipment, it is when you switch them on, it is when your hand is intact with them that they operate. Once you take your hands off them, it is no more working. That is part of engineering control. There are some equipment that requires sensing. They have sensors that it is when you are present that they operate, and when you are out, they don't operate. And when someone gets inside that particular equipment, they stop operating. These are part of engineering controls. Engineering controls can be used to automatically prevent exceeding a particular set limit, or maybe in a crane operation, there's a lifting operation, there's a particular weight that a particular crane is meant to lift. If it's lifting something exceeding, the crane can give some kind of sound or alarm, or even stop. Another very simple example of engineering control is your thermostat in your iron. Once the heat gets to a particular level, it breaks the flow of current, which makes you to maintain a particular temperature. So you can see this in so many cases. On the construction side, you can see engineering control being applied in so many equipment, that it is when you are with the equipment, when you are pressing a particular button, that it will operate. Once you are not holding that particular equipment, it will not operate. And so many examples of engineering control. Then the next one is adaptive control. Adaptive control are meant to guide the other controls. Let me put it that way. Your permit to work system is an adaptive control. Your developer risk assessment, doing trainings, they are all adaptive controls. The signages that you see around, they are all adaptive controls. They do not have a direct impact, but they help to create an environment. They help to create a workplace where people are conscious about safety, just like normal administration of the whole activities, whether engineering, whether substitution, whether elimination, is adaptive control that will help us in understanding more details about the control measures that you put in place. They don't have a direct impact, but they have a whole lot to do. With adaptive control, everything will be in serious mess. It's adaptive control that will tell you that you should use engineering or you should use substitution and the likes. Then the last one is adaptive control that will guide you generally on your site activity. Then the last but not the least, which is the PPE. The PPE can be a saving grace. That body harness can be the only saving grace after you apply all controls. Every other control can fail, and the PPE can help you to reduce the impact, because that's what PPE will do. PPE will not prevent accident from happening, but when it does want to happen, it helps you to reduce the impact if it is applicable. There are some things that the PPE may still not help you to do, but it's the last line. It's the last line of safety. When every other control fails, we expect the PPE to be able to protect you. And there are so many examples of PPE. Your face shield when you're doing your welding, when you're doing your grinding and cutting, your hard hat, your hand glove, your nose masks, your hair plugs, your safety boots, your reflective, your coverall, all these, your body harness, all these are examples of PPEs. You can add your own other controls like we used to see in various other subject matter knowledge on safety. They all fall under this category. See you in the next video.